Good day, everyone. So, for today, we were talking about the arithmetic progression and geometric progression. And we will also try to solve the 5 questions or problems as using these formulas. So, arithmetic progression and geometric progression is defined as a series of numbers whose difference of any two consecutive terms of which is constant, called the common difference, which is represent as d. So let's begin with uh, an. An is a term used to represent the end term or the last term, which is this and this, plus the d, just like I said earlier, they called which is the constant, called the common difference, which is represented as a d, times n, uh, which is number of terms minus 1. Then the second one is the Sn, means the sum of n term equals n over 2 times to the value of the first term, or I mean a sub 1 plus uh um which is uh an, just like I said earlier, which is the term used to represent the end term or the last term, plus the a sub 1, the a sub 1 plus a sub n um raised to n over 2. So another formulas, uh, this is also related in the arithmetic progression and geometric progression. This formula is can use to finding the sum of terms. So the sum of n term is equal by 2 to the value of 2 times the first term in a sub 1, plus common difference, which is d, times n minus 1. So let's try solving a problem now. So here's the problem number 1. What is of an what the first of an arithmetic progression is 3 and the 15 terms is 45. Find the sum of the first 15 terms. So the a sub 1 is equal 3. So this we have the first term, which is, as I said, a sub 1 is equal 3. Then the last term, which is a sub n, is equal 45. And our n is equal 15. The numbers of terms, which is 15. Then we are the tasked to find the sum of the first term, which is the a sub 15 or the a sub n. So now we can use the formula for the sum of n term. So these are the formula. The a sub n is equal n over 2 times a sub 1 plus a sub n. So again, now that we already rewrite the given numbers. Then let's substitute the values of each value. I mean, substitute each value. So the sum of n becomes the sum of 15 terms equal our numbers of terms is 15 over 2 times the first term, which is plus the last term, which is 15. So therefore, in these values, we add this. So therefore, 3 plus 45, it becomes 48. And then over 2. So let's simplify. I mean, now that we already simplified the first term, I mean the last term, that is the I mean this is our answer. So the next thing to do is just divided. So the answer of, I mean, multiply this, I mean sorry multiply this to the 48. So therefore 15 times 48, it becomes 720 over 2. Then the last thing we do is just divide it by 2. So 720 over 2, I mean 700 divided by 2, it becomes 360. So therefore, our answer for the problem number 1 is a sub 15 is equal 360. Let's proceed for our problem number 2. So here's the question. In a certain arithmetic progression, the 20th term is 32 and the common difference is 3. Find the first term. So again, we're using the arithmetic progression formula, which is this. A sub n is equal a. So these are our given numbers. 20 is equal 32, and is equal 20, d is equal 3, a sub 1 is equal, I mean is equal, right, is equal blank or question mark. So again, we're using the this formula. So now that we rewrite it already, which is this, the 3n is equal 20 over 2 times a sub 1 plus 32. It becomes the 10, because 20 divided by 2 becomes 10. Then copy this value, which is times a sub 1 plus 32. Then after that, the 10 times by 32, therefore it becomes 320. Then we only have to do now is just multiply this by 10. So a sub n, I mean 10 a sub 1 is equal 10 over 10 is equal negative 320 over 10. So therefore our answer is a sub 1 is equal negative 32. So this is our answer for number 2. So here's our problem number 3. Again, we're using the arithmetic progression formula. This is our last problems. Then now we proceed our problem number 1 and 2 or 4 and 5 using the geometric progression later on. So here's our questions. The first term of an arithmetic progression is negative 2 and the sum of the first 11 term is 88. The common difference is question mark. So here's the given questions or given numbers. So our A is equal negative 2. Then A sub n or A sub 11, which is our first term, is equal 88. Then our end is 11. Then D is our question mark. So again, we're using this formula, the arithmetic progression formula. So now that we rewrite it, or we change to our given questions, for this question rather. So the A sub 11, they changed 88 because the first term the first 11 term is 88. So it becomes 88 is equal 11 times negative 4. It because 2 times negative 2, it becomes negative 4 plus D times 11 minus 1. Therefore, 10D over 2. Then now, 88 plus, equals negative 44 is because 11 times negative 4, it becomes 44. Negative 44 over 2 plus 10D times, we multiply by negative 4, it becomes 110D over 2. Then after that, 88 is equal negative 22 plus 55D. It because it divided by 2. We divide it by 2. So 44 divided by 2, it becomes negative 22 plus 110 divided by 2, it becomes 55. So we add this, the first term, which is 88 plus 22, it becomes 55. We add this, then 55D. So here they are. The 110, we divide it by 2, it becomes 55. Then 55D divided by 2, that is 0. So the answer of the common difference is D is equal to. So here's our answer for our problem number 3. Now, we can try solving the geometric progression problems. So, geometric progression is defined in a series of numbers who used ratio of any two consecutive terms of which is constant called the common ratio, which is represented with the letter R. That is the common ratio. So here's here the formula using the geometric progression. So a sub n is equal the end term or the last term is equal to the a sub 1 as the first term times the common ratio, which is r, to the power of n negative 1. N is the end term or the numbers of terms. And the second one, this formula is and the formula for finding the sum of n terms. This is difference, but it's part of geometric progression formula. So therefore, they are another a formula, which as I said earlier, this formula is to find the sum, to find the sum of the n terms, which is a sub n is equal to a sub 1 or the first term times 1 minus the common ratio to the power of n over or divided by 1 minus the common ratio. So let's try solving now the geometric progression problems. So here's our problem number 1 or problem number 4. So if the question, if the first term of a geometric progression is 27 and the fourth term is negative 1, the third term is. So now let's write our given numbers, which is a sub 1 is equal 27, and our a sub 4, which is negative 1, because they said this the fourth term is negative 1, so therefore a sub 4 is equal negative 1, and our end, of course, the 4, and a sub 3, which is our missing here. And as I said, this is the formula of geometric progression. So we write it now. We write this by copying this formula. So now that this is now the a sub 4 is equal to 27 times the common ratio or r to the power of 4 negative 1. So we only have to do now is just write the negative 1. The a sub 4, it changed to a negative 1. So here they are. Is equal 27 times the common ratio to the power of 3. 3 because 4 minus 1, therefore becomes 3. So after that, the 27, we divide it by 27. So negative 1 over 27 is equal 27 times common ratio over 3 over, I did to the power of 3 over 27 times the common ratio to the power of 3. So we know that we already multiply it or divide by it, sorry. Now that multiply now, so 3 to the square root of the common ratio to the r to the power of 3 is equal square root of negative 1 over 27. So 3 times 3 is equal 9 times 3. Therefore, it becomes 27. So our answer is r, or the common ratio, is equal negative 1 over 3. So the answer of our a sub 3 is equal 3. So this is also same. The formula, I mean the same ways or other ways, sorry, to find the answer using the geometric progression. So let's proceed for our last problems, which is problem number 2 or problem number 5 using the geometric progression. So the sum of an infinite geometric progression is 2 to the square root of 2 plus 2. So if the common ratio is 1 over square root of 2, find the first term. So we now that we copy the given numbers. So a sub infinite is equal to the square root of 2 times, plus 2, and our common ratio is common ratio is equal 1 over x squared, square root of 2. Then our a sub 1 is missing. Then our s is equal a sub 1 over 1 minus the common ratio. So now that we add this together, so it becomes 2 to the square root of 2 plus 2 is equal a sub 1 over 1 minus negative, minus 1 over square root of 2. So here they are. We translate or rewrite it in this kind of way. So here they are. So a sub 1 is equal 1 minus 1 over x square root of 2 times 2 square root of 2 plus 2. So it becomes 2 square root of 2 plus 2 minus 2 square root of 2 plus 2 over 2. So we write it this. So 2 square root of 2 plus 2 minus 2 plus minus 2. So we cancel out. Cancel. So the remaining is square root of 2. So therefore our a sub 1 is equal square root of 2. So here's our final answer. So these are the missing. The square root of 2. That's it.